Hello everyone. In this video tutorial, we are going to build a recruitment assistant application that will help recruiters understand technical job offers. So many recruiters often find it challenging to understand the technical job offers like DevOps engineer or help desk IT manager, and this can lead to confusion during the hiring process. Our solution will be based on powerful AI techniques like large language model fine-tuning, function calling, and AI agents. This tutorial will be step-by-step and practical. We will begin by generating our own training data using generative AI to parse and transform job offers. Then we will fine-tune large language model Qwen 2.5 14 billion using Anslot library. This will result in a capable local model that understands technical job offers. We will save the model on Hugging Face for easy access later. After that, we will evaluate the model and explore 4 different ways to use it. First, we will use it to generate markdown outputs that explain the job offer and provide more insights. Then we will build a web application using Radio. We will also show how to use it with Gemini 2.5 through function calling. And finally, we will use the new model from Llama 4 Scout, to build a fully capable AI agent. This AI agent will use our model as a tool to enhance the chatbot capability. By the end, we will have a complete AI working solution built with the latest AI tools. And also you will have a clear understanding on how each piece fits together. So without further ado, let's jump directly to the notebooks. This tutorial comes with a detailed blog post covering all the core steps and results. You will also find a link to the GitHub repository right here. Just click on it and you will land directly on the project page. There you will get access to the dataset, notebooks, and everything you need to follow along. To keep things organized and easy to follow, I've split this tutorial into 3 notebooks. The first notebook is for data preparation, the second notebook is for model fine-tuning, and the third notebook is for inference and AI agent building. This way you can focus on exactly what you need. So, before we dive into the first notebook, I want to ask you for a quick favor. If you are enjoying this content so far, don't forget to like, subscribe, and help us hit that 1000 subscriber milestone. Alright, let's start and open the first notebook. The goal from this notebook is to create the training data that we will fine-tune the model based on. First, let's start by importing pandas and open the CSV file, which you will find in the GitHub repository. The CSV contains more than 1000 job offers. We are only going to use 500 to fine-tune the model on. So first, let's see the desired output that we want the generative AI model follows and generate something like it. We want a role summary, which is a concise, non-technical summary for the job, key terms, the skill priorities, a list of must-have skills and nice-to-have skills. Also, we want the model to generate proposed screening question with answers, can help the recruiters ask technical questions and assess the answer of the candidate based on that example answers, and also red flags, which is an indicator of potential mismatch for the role. For example, avoid candidates without cloud experience. And lastly, a confidence score, which is a numerical score between 0 and 100, indicating the model's confidence in the accuracy of its analysis. So now let's build the system message prompt based on that JSON schema. And we are asking the AI model to follow it and giving him some guidelines and rules to follow. For example, the output should be in JSON object without additional text. First, we are going to install Grok, which is the cloud provider for the large language models we are going to use. Here, as you can see, we are going to label 500 job offers, so we need multiple accounts to work on that. So I generated 3 keys, API keys from different accounts, and all the accounts are going to use the Llama 3 70 billion model. In order to guide the model to respect the desired output, we are going to import base model from Pydantic and create our class, which is job analysis, that contains all the keys that we shown before. Next, we are going to create the function analyze job with retries. This function will analyze job description with API key rotation to respect the quota and to continue generating the 500 desired output. Once we have this function, let's do the inference on this example of job description and see the output. Okay, so we are using, as I said, the Llama 3 70 billion model, and as you can see, the model respected all the keys and there is no error in the output. Because as you can see here in the function that we defined, we are validating the JSON output based on the job analysis, which is the Pydantic class. So if the output is not respecting the keys, the model will retry and create another output that respects the desired keys. So this function here shows how we are going to apply the previous function on a data frame using progress apply. And this will create a new column in the data frame called parser description that contains the job description based on the job offers column. For now, we are not going to regenerate, so let me show you how this combined jobs with analysis CSV file looks like. So here's the final CSV file that contain the parser description based on the job description, which is under this detail column. Also, we have some extra columns that we don't need for this tutorial. So the detail contains the complete job offer, and under the parser description, we have the JSON object that we generated based on this job description. So with this CSV file in hand, we can move to the next step, which is fine-tuning the large language model to generate this type of output. The goal is to create a local model that is capable of generating this same type of JSON object that describes any technical job offers without sending the company job offers to a third party, and also with less cost. We chose the Qwen 2.5 14 billion model to use the maximum of the free Collab Notebook GPU. We use the Ansloth provided notebook. First you start by doing the installation, and then you choose here the maximum sequence length. The load in 4-bit, we use it in 4-bit quantization to reduce the memory usage and to have the quantized version of the model. We select the model and tokenizer from fast language model dot from pre-trained. We select the model name Ansloth Qwen 2.5 14 billion, and also we add the Hugging Face token because it's needed for gated models. And we can see that the Tesla T4 provided by Google Colab has a max memory of 14.7 gigabytes. After that, we add the LoRa adapters, so we only need to update 10% of the parameters. Now the model is equal to fast language model.getPeft model, which is parameter efficient fine-tuning, and we keep the parameters on their default value, 16 for R and 16 also for the LoRa alpha. And as a result, we can see that Ansloth patched 84 layers, QKV layers, O layers, and MLP layers. For the data preparation, we are going to use the Alpaca prompt template. First, we start by importing the CSV file. The Alpaca prompt template starts with an instruction, which is the previous system message we used, and then the job description and response. During the training, we are going to feed the job description here and the output that we have already generated as a response. And during the inference, we feed the job description and we take what the model will generate after the tag response. Here is the formatting prompt function that will format the two columns from the CSV into one single prompt that the model will take as an input. After that, for training the model, we use the Hugging Face TRL Safe Trainer. You can select the max steps, or you can just set the number of train epochs equal to 1 for a full training run. Here we select the quantized model, the tokenizer, the dataset. We use 5 steps for warm-up, and Adam W 8-bit as an optimizer, and the learning scheduler type is linear. We start the training. We can see that the GPU max memory is 14 GB and 11.6 GB of reserved memory. We start the training and we manage to decrease the training loss from 1.5 to 1.03 after 62 steps. And this whole process took 1 hour and 15 minutes, and the peak reserved memory equal to 14.5 gigabytes, which is almost 100%. Thanks to Ansloth, we are capable to fine-tune 14 billion model on a free Collab notebook by using practically 100% of the free available GPU. For the inference, we have an example of job offer, and we can see that this is the complete Alpaca prompt plus the response. All we need to do is to parse it after this response tag in order to have our final JSON object that starts from the role summary and ends by the confidence score. And from this first site, we can say that the model successfully respected without hallucination the desired output with the predefined keys. Then we can save the model to do the inference on a separate notebook without keeping the model in memory. So we can save both the LoRa adapters and the GGUF version of the model. Keep in mind that when doing model.save pre-trained LoRa model, you are only saving the LoRa adapters but not the complete model. And now we can use the LoRa adapters from Hugging Face directly by selecting the model name that we chose for our LoRa adapters, and also by setting the load in 4-bit to true. It's more clear here when using the indentation. We can see that the fine-tuned model successfully generates the role summary, key terms, which is a list contains the term and the explanation, also the must-have skills and the nice-to-have skills, proposed screening questions, and the red flags, and finally the confidence score. Finally, we can save the GGUF llama.cpp conversion and uploading them directly to Hugging Face following these 3 supported quant methods, Q8, Q4, and Q5. This process will take some time, but eventually you will have the models on your Hugging Face repository. I have the LoRa version for both the Qwen 2.5 7 billion, 14 billion, and also the Qwen 2.5 7 billion GGUF. With that being done, we can move to the third and last notebook, which will use this model as a separate tool and call it whenever we need it. In this third notebook, we will see how to do the different type of inference, use the model as a tool, and build the AI agent. First, let's test our fine-tuned model. We import the necessary libraries, we prepare the alpaca prompt, and we start by the base model inference. Then we will do the fine-tuned model inference, and we compare between both outputs, do the markdown output, build the Gradio application, create the function calling with the Gemini API, and finally building the AI agent with Llama 4 Scout. We import the base model and test it on job offer. We have this alpaca prompt, we need to fill it with a job description here. We keep the output blank. So first let's bring a job description from LinkedIn and we insert it here. Okay, so now we have this job description, and let's see if the base model will succeed to generate the desired output that we predefined in the prompt or not. So after taking 53 seconds, the model generated this output that contains the role summary, it's good, the key terms, the must-have skills, proposed screening questions with answer, red flags, but it didn't stop there. It started the generation of another output again, and this output this time is a duplication of the previous one. So the output is not very consistent. So when I tested this in other job description, I noticed that the base model didn't succeed to generate consistent outputs with some weaknesses like missing or adding some extra commas, incorrectly formatted data that doesn't respect the JSON format, and the incomplete JSON by not adding the complete fields that we mentioned in the prompt. Now let's import our fine-tuned model from the Hugging Face repository, and let's see this time if this fine-tuned model will do a better job. And now let's see the result by running this same function. So first thing we can notice that this fine-tuned model took 49 seconds for inference, which is practically the same time as the base model. And now let's evaluate the answer. We have the role summary, the key terms, the skills, proposed screening question with answers, red flags, and confidence score. And there is no hallucination, so the output is consistent and clear. And with that, we can remark that the fine-tuning job that we did improved the output of the model to respect the system prompt, especially with larger job descriptions. Now let's move to the second part, which is the markdown output. So once we have this JSON output, the first thing we can do is to parse it and create a markdown text that is easier to read and contains all the information as we can see here. Next, let's build the Gradio application. First, let's install Gradio. Next, let's import it. We create this Qwen job parser function that will wrap the model and take the job description, the model, the tokenizer as input and return the parsed JSON as output. Now let's run this function that contains the customized CSS and run the Gradio application. We get a job description from LinkedIn, we pass it as input, and we can see that the outputs are easy to read, separated in different windows. Now we move to the function calling with Gemini API. The function calling lets you connect models to external tool and APIs. In our example, the tool is the function that will wrap our model and generates the JSON outputs. So here's how it works. The application will send the prompt to the Gemini. The Gemini will decide what to respond, either to do a final answer based on its knowledge or to do a function call and return the function name and arguments. We parse this output by taking the function name and argument, do the inference, and return to the model the result of our function. The model then will decide to respond based on the result of the function call and give us the final answer. The first step is by define function declaration. We define the function and its declaration here, the name of the function, the description, and the properties. The required one is the job description. Then we create the function, which is markdown job parser. It takes the job description and returns the markdown output. We have this message here to mimic an input from a recruiter that wants to understand this technical job description. We import Gemini from Google and then we declare our tools list containing only one tool. The system message is set like that. You are a helpful assistant. If a response comes from a function call, return it as is without modifying or rephrasing it. We can see here when the model is parsing the message input, it will return the arguments, which is the job description, and at the end we have the name of the function, which is markdown job parser. We parse these two arguments and we get our final response. Step 4 is to create a user-friendly response with function result and call the model again. Finally, we send the result of the function execution back to the model so it can incorporate this information into its final response to the user. Or we can send it back as it is without giving the model the possibility to modify it. So this is the final result based on the results given from our tool. Okay, now let's start the final part, which is creating the AI agent with Llama 4. In this section we will use Llama 4 Scout. We first install Grok and Rich. We declare our function the same way we did with the Gemini. We declare the job parser function. We get our API keys. We import print from Rich. And we start by defining the history that contains the system prompt. We define also the tools list, the model that we are going to use, and we need to handle when the model decides to use the tool or not. The discussion will start with the user input and it will end with exit. Whenever we have an input, the model will make an API call to Grok, generating a response. If this response is final, we will return it. But if a tool is called, we will to handle that by processing the tool, getting the name of it and the arguments, doing the call to the tool, getting the information from the tool back, and generating the final answer. Okay, now let's test the capability of this AI agent. So let's start by saying hello. How are you? As you can see, the chatbot is completely conversational. And now let's ask him a question about job description and let's see if the tool will be triggered or not. Please help me understand this job offer. The AI agent didn't answer directly. The tool is detected and the tool name is job parser. So now the job parser tool is getting the information I passed to the chatbot, processing it, and returning the output to the chatbot so he can answer us based on this information. As we can see here. And finally we can type exit to finish the conversation. So with that we came to the end of this tutorial, guys. If you enjoyed it, like the video, subscribe, and follow me also on Medium, and also I'm open to your feedbacks and comments. Thank you and see you in the next video.